Now in the lecture 1 to prepare polymers, we have done addition polymers and we were in condensation polymer. Condensation polymer, we have done nylon 6, terylene and bakelite. Now I am doing the 5th one, that is urea formaldehyde polymer. Urea formaldehyde. See, I take time to write, correct? So ना अपने दिमाग में ना या रिवाइज करते रहा करो. Urea formaldehyde polymer. So you will remember, yeah, urea formaldehyde polymer is a condensation polymer. Many times memorization helps a lot to answer the MCQ quickly. You can keep on revising because I take time to write. So nylon 6, nylon 6, terylene, bakelite, urea formaldehyde polymer are condensation polymers. Now the monomers used are, it is very much clear in the name. We have to take formaldehyde and we have to take urea, isn't it? So urea and formaldehyde. So I hope you know the name. This is formaldehyde and this is urea. Now see what happens is, this is formaldehyde CH2, that is this. The pi bond breaks of oxygen and becomes sigma, one sigma with H, another sigma with NH. One of the H of NH2 has gone here with the O of the formaldehyde and remaining as it is. Did you get me what I did?
Yes.
Okay, if you really understood, tell me now other side how the reaction will take place. Can you tell me?
OH, CH2, NH,
This will be NH, CO.
C double bond. Then
Now,
again NH,
yes, very good.
CH2, OH.
Very good, Prithvi. So this is how we have used two molecules. This is the intermediate. Now, a polymer will not have one or two molecules, but it will have many molecules. So when we take n number of these molecules and we polymerize, then after polymerization, we get urea formaldehyde polymer. Now see what happens. This is eliminated in the form of water with the adjacent molecule. One OH and H goes. So how the bonding is formed? N CH2 N. Can you see this? N CH2 and another molecule N gets connected and the OH is out. So NCH2N and then CON. So this is that urea part. This. See, I am explaining here. See this. This is that urea. N NCON. That is this NCON. What I didn't write? H. H goes along with the OH and makes another bond, and यहाँ पे वापस क्या आएगा? NCON. Again down क्या आएगा? NCON. So from the urea we take NCON, and from the formaldehyde H2 goes. Again, can you tell me what will come?
NCON.
No, first a formaldehyde methylene group in between to link. See, the urea will be linked by the formaldehyde link. Are you getting me? So NCON. Now just think what will come. How to connect these two N. ये यूरिया है, ये
C
formaldehyde.
double bond O.
वापस यूरिया है, formaldehyde है, वापस यूरिया है. So now what will come? Yeah.
C double bond O.
No, my dear. See, you did not get it what I am saying. See, is this is urea? This is urea?
Yes, ma'am.
This is urea?
Yes, ma'am.
This is urea. Now think, in the process of polymerization, two urea are linked by
CH2.
methylene. Methylene is coming from?
Formaldehyde.
Now again, these two urea will be linked by?
CH2.
So here what will come?
CH2.
Is this clear?
Yes, ma'am.
And similarly, now from here, another link. Now can you tell me here CH2 will come or N will come?
CH2.
Yes. And then again NCON. Now you understood. Good. Why others are not answering? Is it not clear? Is it not clear, beta?
It is clear, ma'am.
Okay. So this is urea formaldehyde resin. Now in exam, what you have to keep in mind? See, we will see the details in the mechanism. That is a different thing. But just to, quickly recollect it in exam, what you have to keep in your mind? That the two urea molecules. Now, one thing I want to ask you here, tell me what is the mistake in this structure?
Ma'am, N should be joined to C double bond O.
Good. Here N should be joined. Very nice. Because amine is dash NH2 and not NH2 dash. It is dash NH2 and not NH2 dash. Correct? So the bond should be with N. So this is urea and this is formaldehyde. So see what you have to keep in your mind. Are you looking at the board? Hello?
Yes,
Yes,
ma'am.
ma'am.
This is how water goes. Did you get me?
Yes, ma'am.
ma'am.
Okay. So this you have to keep in your mind. Are you writing it?
Yes, ma'am.
So
Yes, ma'am.
shall I change the page?
Done, ma'am.
Okay. Okay. Now we go to the sixth one, and that is melamine or formaldehyde melamine. Are you revising how many condensation polymers?
Yes, ma'am.
How many? Tell me.
5.
Yes. What are they?
Nylon 6. Nylon 6,6. Terylene. Urea formaldehyde. And the last one, melamine.
Good. Now monomers used are melamine and formaldehyde. So I am making melamine. Okay. This is melamine. Formaldehyde. Tell me the structure.
HC double
He
bond.
double bond OH.
Same type, just like urea formaldehyde, isn't it? Exactly same, because there also it was NH2 and formaldehyde, isn't it?
Yes, ma'am.
Yes, ma'am.
Exactly same. If you know the one, you know the other. Now see, I am writing this NH2. I am writing this H2N. Can you tell me how reaction take place? If you remember.
NH. CH2OH.
NH.
OH.
Now see, I will do that on all the sides. See what I am doing. Are you paying attention?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Same thing I will do here. Same thing I will do here. Okay? Right?
Yes, ma'am.
Now how this will happen, if you want, we can see that also. I am just removing this arrow. And don't copy right now, just wait. I am explaining you something. Now I am copying this intermediate so that you understand the method. This is what we took. Same thing will be here. It will be NHCH2H. You can also write NH2. It is understood we will be taking that. Now I am taking its N molecules, meaning this intermediate, I am taking how many? N. Okay, and I do polymerization. Do you remember from CH2OH what goes in urea formaldehyde? What?
Water.
Yeah, no.
Water.
Which group from here? From here.
OH.
Yes. So, we can just understand this goes, this goes, this goes, and they get connected one after the other in continuity from here. Do you get me? This is the continuous chain. Okay?
Yes, ma'am.
So this is
Yes,
the
ma'am.
melamine polymer. Now you can write it. Over?
Yes, ma'am.
So this was condensation polymers. And addition polymer and condensation polymer is also a type of classification of the polymers, but that classification is based on the process or the method by which we are obtaining it. Okay? Now we
Yes, ma'am.
will do one more classification, one more category, and that is, you can give the heading classification based on molecular forces. Classification based on
Molecular forces.
Just understand some certain points which I am saying. You can just jot them down also. Molecular forces bind the polymers by hydrogen bond or van der Waals forces. What I said? Molecular forces bind the polymers by hydrogen bond or van der Waals forces. These forces are called intermolecular forces. And the properties of the polymers depend on these forces. And the properties of the polymers depend on these forces. Shall I repeat? Hello, are you there?
Yes, ma'am.
Shall I repeat?
No, ma'am.
Okay. The first category is Please read it. What I have written.
Elastomer.
Elastomer.
Yeah. Elastomers. As the name suggests, they show
Elasticity.
Elasticity.
elasticity. Very good. You're smart. So they are definitely correct.
Yes, ma'am.
And we use them to make okay. Example, neoprene. I gave you that table. I don't know whether you remember or no. Do you remember the monomer of neoprene?
Chloroprene.
Wow, lovely. Is the table in front of you and you are reading it?
No, ma'am.
Okay. So this is neoprene. No, this is chloroprene. And from this we will obtain neoprene. So chloroprene on polymerization. Now beta be attentive. हाँ? थोड़ा ज़्यादा ध्यान देना. Are you looking at the board?
Yes,
Yes,
ma'am.
ma'am.
I'm just writing everything except the
Double bonds.
double bond. Okay. Now I am making the double bond. One double bond is here and one is. Now one of the pi bond. What I did?
Breaks.
The pi bond breaks. Okay. So one pi bond breaks and forms 2 sigma. So this sigma bond that I made here, it contains how many electrons?
1.
Very good. And the remaining one comes here, isn't it?
Yes, ma'am.
One here and one here, isn't it? Similarly, this sigma breaks. Correct? And again, the bond which broke has how many electrons?
2.
One comes here and one electron. Where it
On the
goes?
on the carbon.
So again, I'm showing you something because this will not come here. I wanted you to say that it will come here. Once again, I am making now. See, I am removing this. This part you have to understand very clearly. Okay. Now, once again, I am writing. This was the pi bond, isn't it?
Yes, ma'am.
It breaks from here. Now see what I am doing. Now, what you have to be careful about, it broke between these now. Right? So when it breaks from here, one sigma comes here and one,
Okay.
right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Electrons one here, one here. Same way, I am breaking this. So one comes here and will the other one come here?
Yes.
No.
No.
Oh, no.
Again you did mistake. See, this is the pi bonded region. So if one comes on this carbon, other one will come on.
Okay, yeah. The chlorine one.
Got it?
Yes, ma'am. Yes, ma'am.
That to be very careful. Are you getting me?
Yes, ma'am.
So this what you have to understand very clearly. And now N will come here. And now I am naming it. This is
Neoprene.
this clear?
Yes, ma'am.
Yeah. And we can also make it like this. See, one more thing I am telling you, so you will get one more revision. Suppose I don't write. Suppose I don't write this. Okay. And say I don't write N here. Okay, I am just writing this. Then I can call it.
Repeating unit.
Yes. I can call it repeating unit. I can call it repeating unit, and I can once more I can explain you. Okay. So we broke a pi bond from here.
Yes, ma'am.
Yes, ma'am.
This breaks and it makes 2 sigma. Similarly, other one was here.
Yes, ma'am.
This
Yes,
breaks
ma'am.
and it makes 2 sigma. And then an N here. Is it clear now perfectly?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Please write it. Sometimes students do the mistake, they make here 2 bonds instead of 1.
Done, ma'am.
Which type of classification are we doing, beta?
Based on molecular forces.
Very good. And in that we completed. Meher, in that we completed.
Elastomers.
Correct. Second category that I am going to is fibers. So first was A was elastomers and B is fibers. These polymers show very high tensile strength. They show hydrogen bonding. Example, nylon fibers. And in nylon fibers, the hydrogen bond is between NH of one molecule of one chain and CO of the other chain. Can you tell me what is this dash NHCO together known as?
Amide.
Amide. Also called peptide. That is why nylon fibers are also called the polypeptide or the polyamide fibers. Yes?
Yes, ma'am.
Yes.
They are used to make the ropes or the tire cords. Any need for me to again show you the preparation of nylon 6 and nylon 6,6?
No, ma'am.
You've done
No,
it?
ma'am.
Remember it? We did it in the previous lecture only, isn't it?
Yes, ma'am.
Okay. Now the third category. The third category is thermoplastic. Can you understand the meaning of the name? They have properties intermediate between fibers and elastomers. Okay. Thermoplastic. Thermo means heat. And you know plastics on heating become soft, they melt. Isn't it?
Yes, ma'am.
Yes, ma'am.
Something which becomes soft on heating and cool and hard on cooling is a thermoplastic polymer. They can be remolded and they can be recycled. They can be linear or branched. And all the examples we have done, bacha, polythene, PVC, yes or no?
Yes,
Yes,
ma'am.
Yes.
Okay. So any need to write
No,
preparation?
no, ma'am.
Okay. He is a thermo setting polymer. Can you tell me the meaning now?
It is hard. It won't melt on heating.
No, so we will say they become hard on heating.
Hmm.
Instead of saying they don't on heating, they become
Hard on heating.
hard on heating. And they cannot be remolded or recycled. And the example is known to you.
Bakelite.
Yes. So see, if we did so many preparations now, जैसे जैसे हम आगे बढ़ रहे हैं, काफी सारी चीजें already हो
हो
गई.
चुकी.
Okay. Now we will come to a very important topic, rubber. A very important subtopic, rubber. Now, when I say rubber, I can classify into two categories. One is the natural rubber, and another one is the what?
Synthetic.
Synthetic.
Okay. So first we will see natural rubber. Now some simple things, you know, which we have learned in school also. We'll just have a quick glance onto them. It is obtained from rubber tree. Obviously. You remember in school there was a diagram that latex, collection of latex. I don't know whether you remember or not. And this is in the form of a colloidal suspension. And it is a linear polymer. Natural rubber is a linear polymer of the monomer isoprene. Anyone knows IUPAC name of isoprene? Okay, I'll write it. name 2-methyl-1,3-butadiene. See how the structure will be. One and 3-butadiene, and second पे methyl. Yes.
Yes, ma'am.
Can you tell me what is the difference in chloroprene and isoprene?
It's just 2 chloro.
Huh? Yeah.
Methyl.
Yeah. Now, a very important line which you should learn the moment I write. And that is natural rubber is cis isoprene. That is the polymer of cis form. That is cis 1,4. Can anyone tell me why I wrote 1,4? Let us see how you think. No? Shall I explain? Hello?
Yes, ma'am.
See. Now I want to polymerize this. So my dear, same thing. 1 pi bond from here breaks to form 2 sigma. And one
Yes, ma'am.
which was here breaks to form 2 sigma.
Yes, ma'am.
Polymerization takes place at which positions? Which position?
Second carbon.
No, polymerization तो यहाँ से होगा ना, next तो यहाँ से join होगा ना.
हाँ, मुझे
Yes, ma'am.
डबल बॉन्ड बचा.
Second किधर है भाई ये? Ends है ना, तो number then.
1, 4. 1, 2, 3, 4.
That is why 1,4 polymerization. Got it?
Yes, ma'am.
Yes, ma'am.
Okay. Now we know इसका cis form लेना है. अब देखो इसको cis form में लिखते हैं. CH3, C double bond C, H. इधर क्या है? CH2. इधर क्या है? CH2. Is it cis? See this.
Yes, ma'am.
So this is how it is a natural rubber. Then next molecule, how you can write, how you can polymerize like this. CH2, C, double bond C. What I should write here? Tell me.
CH2.
Correct. And then continuation there. And here, CH3 and H. So this is it clear?
Yes, ma'am.
So cis 1,4 polyisoprene is natural rubber. It has got long flexible chain. It has got weak intermolecular forces. You know now the natural rubber, the one which is obtained from nature, is not so hard. It is quite weak. It is having weak intermolecular forces and it has elastic properties as well. Okay. Now
Yes, ma'am.
let us see what is the transform. Now we know natural rubber is cis 1,4 polyisoprene. So a question that comes to your mind, can you tell me what question must be coming to your mind? What is trans 1,4 polyisoprene? Correct?
Yes, ma'am.
So first let us understand how to make it and then we will see what happens. So how to make the transform? Can you tell me what I will be doing? CH3, C. Now what to do?
CH2.
Correct. And now what to do here?
CH2.
And here?
H.
And then
Continue.
again what? CH,
3.
2.
Okay. 3 से कैसे लिंक होगा? And then
2.
correct. And then
CH3.
CH 3 नहीं हो सकता है।
3.
4 के ऑपोजिट H और छतरी आ सकता है, तो ये क्या होगा? Yeah.
CH2.
Yes. No, it can be H also. How it can be CH2, CH2 on the same carbon, my dear? See, now when you make like this, ना, you can understand in exam. अरे यार ये ऐसा जा रहा है, चेन क्या ये तो बॉक्स बन रहा है. So थोड़ा wrong नहीं है, देखने में थोड़ा अजीब लगेगा. तो अब क्या करने का? Make the structure from the other side. That is, ये ऐसा है, अब इसको ऐसा बनाओ, ऊपर जाओ. Take another molecule. Is that clear?
Yes,
ma'am.
ma'am.
Yeah. Then here you can take CH3 and here you can take H and here you can take CH2. And then again, what is this? Gatta Parcha. What is this?
Gatta Parcha.
So the question was, what is trans 1,4 polyisoprene? The answer is, it is Gatta Parcha, which has zigzag chains, which has got zigzag chains, and it is non-elastic, and it is crystalline in nature. Okay? There is
Yes, ma'am.
a category of rubber which is very famous. Do you know which one I am talking about? Very famous.
Synthetic rubber.
Huh?
Synthetic rubber.
No. That I told you. The answer is vulcanized rubber. We learned it in school. Vulcanized rubber. Now see, natural rubber is made strong by adding, do you know what do we add?
Sulfur.
Yes. So natural rubber is made strong by vulcanization. And Charles Goodyear discovered the process of vulcanization in which natural rubber is made more strong and elastic. Now the process is natural rubber is mixed with 3 to 5% of sulfur and it is heated at 100 to 150 degrees centigrade. It forms cross-linking. It forms cross-linked chains of, can you tell me, cis or trans 1,4 polyisoprene?
Trans.
Cis.
Cis. It is natural rubber, my dear. Natural rubber is cis.
Okay, got it.
Trans is gatta parcha.
Yes, ma'am.
And these chains are formed cross-linked chains. And then the question that can come in exam is, what's the link? The link is dash S dash S dash. Is that clear?
Yes, ma'am.
Now, if I make rubber with 20 to 30% sulfur instead of 3 to 5% sulfur, how much I am taking?
20 to 30%.
So 20 to 30% sulfur is hard. It's quite hard. And the one which contains 3 to 10% sulfur is little harder and is used to make this can come in.
Tire.
And if 1 to 3% sulfur, then it is used in making rubber bands. Okay? So we did natural rubber, we did gutta percha, and we did vulcanized rubber. Now tell me, which category of rubbers is remaining?
Synthetic.
Yep, very good. Synthetic rubber. Anyone knows how many types of rubber are there in this category? Synthetic rubber. No? My dear, Buna S, Buna N, neoprene rubber, and butyl rubber. Okay, which four I told? Simon will answer. Simon, which four I said?
Una S, Una N,
Yeah.
neoprene, and
Simon, I can't see you. Buna S, Buna N. Then Buna S, Buna N, neoprene,
neoprene, and last one I forgot.
butyl rubber. Okay? Which four? Buna S, Buna N, neoprene, butyl rubber. Can you say?
Una S, Una N, neoprene, and butyl rubber.
Very good. Very nice. Okay, let us proceed further. I am making Buna S. Now understand, Buna S is also called SBR. The full form is styrene. Keep on repeating in your Kopadia. Styrene, butadiene, styrene, butadiene, and R for
Rubber.
okay. Can you tell me what to use to make it? It is there in the name.
Styrene and butadiene.
Do you know structure of styrene?
Yes, ma'am.
Please
Yes, ma'am.
tell me, Jay.
Ma'am, it is C6H5. Then it was CH double bond CH2.
H5. Okay, I am making the ring, the phenyl ring, and then CH double bond CH2. Meaning I can also call it vinyl benzene, isn't it?
Yes, ma'am.
Okay, who will tell me structure of butadiene? No one?
CH2 double bond, CH double bond.
So I specified now 1,3-butadiene. N here and N here, N molecules and N molecules. Okay?
Yes, ma'am.
Yes, ma'am.
Okay, let us proceed further now. Now be attentive. presence of K2S2O8. Now be attentive. Are you attentive?
Yes,
Yes,
ma'am.
ma'am.
Keep on telling me what I did not make. Keep on telling me that.
Pi bond.
Keep on telling me.
Pi bond.
Okay. Now I start. Look here. Are you looking at the board?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. This pi bond will break.
Yes.
Tell me. Here one
Yes, ma'am.
and one here.
No.
Here.
Yes.
Yes.
Again, one pi bond will break from here. Another one will complete this.
Yes, ma'am.
Yes, ma'am.
Again, here one pi bond was there. It will break. ये connect हुआ इसके साथ and one here. Is it clear?
Yes, ma'am.
Yes, ma'am.
Somewhere something is missing. O H. Yes.
Ma'am, hydrogen is missing.
I already wrote that. Once again, we will see this. Let us see it once more. What do you say?
Yes, ma'am.
So it will be a good review. So CH. Now I have made everything. Because if somebody could not understand the shortcut, now tell me what to erase. I'll erase one bond from here.
Yes, ma'am.
Yes, ma'am.
One from here.
Yes, ma'am.
Yes, ma'am.
One from here.
Yes.
Yes, ma'am.
Oh, two went. No problem. Just make them. One is here. And this is CH. Two is CH. Okay. Now one comes here. One here. Yes or no? One here.
Yes, ma'am.
Yes,
Complete.
ma'am.
Correct? No.
Ma'am.
No. That means you didn't understand still.
Ma'am, that'll go between.
Shall I make the pi bond or shall I write directly? Please tell me.
No, ma'am, directly.
Directly, okay. One pi bond is here.
Yes.
So breaks to form 2 sigma.
Yes.
One pi bond is here.
Yes.
So breaks to form 2 sigma.
Yes.
One is here.
Yes, ma'am.
So breaks to form 2 sigma.
Yes.
And a,
N.
what is the name of this?
Nice.
SPR. Oh, nice. I hope it's clear.
Yes, ma'am.
You remember you were finding it so difficult earlier. You told me. Chalo, Buna N. Can you guess what I should take?
Acrylonitrile.
Yeah, Buna to same hai, butadiene. And it will be acrylonitrile. So I have to take vinyl cyanide. That is acrylonitrile. And butadiene. That is understood. It is 1,3-butadiene. Shall we write? Yes or no?
Yes, ma'am.
Yes, ma'am.
This is acrylonitrile N monomers, and this is 1,3-butadiene. And now I am making it CH2. Now I'll make it together only. 1 pi bond breaks to form 2 sigma. Is it okay if I go directly? Now,
Yes, ma'am.
yes or no?
Yes, ma'am.
1 pi bond broke to form a sigma here. So CH2. Single bond. Single bond hai and a sigma comes here. Isn't it? CH2.
Yes, ma'am.
Single bond here and here. Is it clear, everybody?
Yes.
Yes, ma'am.
Simon, what I told? What else? Oh, Simon forgot.
What, ma'am?
It's over. Neoprene. Anyone wants me to make neoprene? Hello. Do you want me to make neoprene?
No, ma'am.
No, ma'am.
Okay, what was the last example, Simon?
Styrene.
Huh? Butyl rubber. Butyl rubber is obtained from isobutylene and isoprene. Do you remember what is isoprene?
Yes, ma'am.
Tell me.
2-methyl 1,3-butadiene.
Yes, methyl 1,2-butadiene. Now see, beta, isobutylene is this. I'm just writing rough first. But if you write like this, now you'll be confused while making the polymer. You know why? Because see, here you will say one pi bond breaks to form 2 sigma. Now इधर तुम्हें बना के मुश्किल होएगा. ये वाला पॉइंट खाली रखो. तो कैसा करने का? ये जो छतरी है ना? हेलो 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 हेलो.
Yes, ma'am.
Yes, ma'am.
नीचे लिखने का. तो when you say 1 pi bond breaks, तो ये बराबर तुमको मिलेगा बनाने के लिए bonds. Getting me?
Yes, ma'am.
Yes, ma'am.
That is the art of writing organic, which makes it simple. So I am writing it that way now. CH double bond CH2 and CH3 here, and I'm just erasing the name. You know the name. Yeah.
Yes, ma'am.
Now see, I'll just write. Are you there?
Yes, ma'am.
Yes, ma'am.
1 pi bond breaks to form 2 sigma. One here. This H will not come here. Correct? So here C and here C. Correct? Hello.
Yes, ma'am.
Yes, ma'am.
2 sigma. Through this, who will join? This will join, isn't it? So I am making it CH2. Pi bond becomes single. And here, 1 pi bond from here. breaks to form 2 sigma. So 1 here and 1 here. Is it
Yes,
clear?
ma'am.
Yes.
Yes, ma'am.
Now what is remaining in this topic is biodegradable polymers. Okay. Only 3 more preparations we have to learn, beta. That is polyhydroxybutyrate, copolymer with beta hydroxyvalerate, and we have to learn the preparation of dextran, and we have to learn the preparation of nylon 2, nylon 6, which I'll be doing in the next lecture, because so many preparations at a time you'll get confused. Now what you have to do is you practice them at least 5 times, make them
Okay, ma'am.
become permanent in your head. Okay?
Okay, ma'am.
I think everybody will not write. Nobody else is saying okay.
Yes, ma'am.
Yes, ma'am.